So the next example, we let f of x equals the following function x squared in this case, minus 8x plus 9. Here again we need to do two things. First part, we want to find the derivative f prime of x, again by definition. So let's write by definition. And part B, we want to find the equation of the tangent to f of x at x equals 3. Okay, so this is really a typical test question, quiz test question, final exam question. Well, final exam we'll have other techniques to find the derivative, but to start with the definition, f prime of x will be the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, this is the definition of the derivative, and I repeat that so it will occupy an empty space in our gray matter. So it will be the limit. Go ahead and multiply by 1 over h, and let's evaluate f of x plus h. In this case, we'll have x plus h squared minus 8 times x plus h plus 9. Okay, and then all I need to do is subtract x squared plus minus 8x plus 9. So I'll go ahead and do it. Well, let me write it like so. I'll just copy and close. So I need to do another set of parentheses right there. This will give us long expression. And let's see, when we clear the parentheses here, you have x squared plus 2xh plus h squared minus 8x minus 8h plus 9, and then clear the parentheses here, get negative x squared plus 8x minus 9. Okay, I did it fast, so okay, so expanded x plus h, clear the parentheses, so you have negative 8x and negative 8h plus 9. And we start with x squared and x squared being reduced. Let's see, what else? Negative 8x and positive 8x, and then positive 9 and negative 9. Okay, and what survive after all of that is the h squared and negative 8h. So we have a long expression, and all of a sudden, boom. I have somewhere else 2xh. So thank you. So let's add that. And when you multiply it by 1 over h, then what left now is, let's get to the 2x, and then we have plus h minus 8, right? And now by substitution, you get, when you let h goes to 0, you end up having 2x minus 8. So f prime of x equals 2x minus 8. and this will be the answer for the first part. So after you do it a couple of times, you see that the limit definition is not that bad. Of course, so far we used it for polynomial. We need to check to find out if it works well for other functions. It does. We are not going to show all the transcendental, not all the group of or families of functions. I'm going to show you just few, and maybe few transcendentals as well. But we'll move quickly to chapter 3, where we have a bunch of shortcuts, and we're no longer required to go back and look at the definition. But so far, this is the tools that we have, so we need to work with it. Remember, part B, we need to find the equation of the tangent. Well, we know that the slope of the tangent, let's say at x equals 3, is really f prime, the derivative, at x equals 3, and therefore it will be 2 times 3 minus 8, so it's negative 2. 6 minus 8. So we have the slope, and we need to find the point. We have x equals 3, so we need to find what is the value of y when x equals 3. So it will be 3 squared minus 8 times 3 plus 9. And let's see, this will be 9 minus 9, so it will be negative 24. No, 9 plus 9 minus 24. So let's see, 18 minus 24, so it's negative 6. Did I get it right? 9 and 9 is 18, and minus 24, right, negative 6. So we have the y value is negative 6, the slope is negative 2, so y equals, y value is negative 6 minus 2 times x minus 3. This is the point slope formula, and we end up having negative 2x, negative 6 plus 6. Wow, that's it. Y equals negative 2x. So the tangent, y equals negative 2x. Okay.